Hello everyone. So remember that we are working in lesson 1, properties of integer exponents. So to be successful in this section, we need to know how to evaluate numerical exponential expressions. That so far this week we've been doing good. So we're going to see this example. So I have that Jacob decides to save money for a new tablet. He will save $3 the first week and then he will triple that amount. Then he will triple that amount he has saved each week for 5 weeks. You need to write and evaluate an exponential expression to find how much money Jacob will have in his savings in week number 5. So in this case, what we are going to do is represent the problem with repeated multiplication and exponential expression. For example, week 1, he only put $3. So if he only puts $3, that means it's 3 to the first power. That reason why we have that 3 is equals to 3 to the first power, because 3 to the 1 is equals to 3. Then on week 2, he's tripled that amount. So 3 times 3 equals to, I'm going to write it here, 3 times 3 is equals to, question, how many times did you multiply that number? 2 times, so it's 3 to the second power. Then on week 3, we are tripling that amount from week 2. So we are adding one more, 3 times 3 times 3 equals to 3 to the third power. Remember, we count how many times we are multiplying. So that's my exponent, 3 to the third power. Then in week 4, we add one more, so 3 to the 4. Week 5, so 3 times 3 times 3 times 3 times 3, 3 to the fifth power. So in this case, week 5, the expression is going to be 3 to the fifth power. If we evaluate that expression, that means we are going to multiply 3 how many times? You count 1, 2, 3, 4, 5. And then we multiply 3 times 3, 9, times 3, 27, times 3 times 3 equals 243. So in this case, the solution is Jacob will have $243 in his saving in week number 5. So that's an example. Then they are asking me a couple questions, and it says, look at the table, okay? How many times greater is the amount in Jacob's savings in week 3 than in week number 2? So we are going to look in week number 3, okay? So here's my week number 3. And here's my week number 2. So the question is, look at the table. How many times greater is the amount in Jacob's saving in week 3 than in week number 2? So in this case, how many times? Is 3 times greater. So you can write here 3 times greater, okay? Because we add one more 3 over there. So 3 times 3 equals to 3 squared. 3 times 3 times 3 equals 3 to the third power. So 3 times greater than. So number 2, how much will Jacob have in his account in week number 3? So what we are going to do. Okay, week number 3 we know is 3 to the third power. So that means we are going to multiply that base 3 times. So 3 times 3 times 3 equals 2. 3 times 3 is 9, times 3 is 27. So your solution, remember that we were talking about money, so it will be $27. Okay? Number 3, Jacob thinks that 3 to the fifth power is 5 times 5 times 5, or 125. Explain what Jacob is doing wrong. And to explain that problem, we need to understand where is the base. Is the number being used as a factor in an exponential expression? So in this case, your base is 3, okay? And the exponent is the number that shows how many times a base is used as a factor, or how many times we are multiplying that base. So in this case, 5 is the exponent. So what we can write here as solution. Jacob is confusing in this case. You can write Jacob is confusing. In this case, the base and the exponent. Okay, so 3 is done. We're done with number 3. Number 4. So now we have here, Margot's dad offers to give her 5 cents on Sunday. So I'm going to underline this one. So 5 cents on Sunday. Then for each day of the week, he offers to give her 5 times the amount from the previous day. How much will he give her on Saturday? Write an expression that shows how much Margot's dad gave her on Saturday. So here, Margot's dad starts on Sunday. How many days in a week? We have 7 days in a week. 7 days in a week. Okay? Every day he is going to give, okay, 5 times the amount from the previous day. So in the first day he gave 5 cents on Sunday. Then he will 5 times that number. So in this case, the base is going to be the amount that he is going to give, and the exponent is going to be the number of days. How many days? 7 days in a week. Okay? And then if we multiply, this will be 5 7 times. So I have 5 times 5 times 5 times 5 times 5 times 5. How many do you have? 6 is equals to, in this case, 78,125 cents. Remember that we were talking about cents. Now we need to know how much dollars is that. Okay? So those are cents. And remember that $1 is 10 cents. So in this case, she will have, in this case, this is dollar amount S, 78,125 will be equals to 781.25 cents. Okay? So that's what we are doing with those problems, with those examples, to solve it. So now, if we move to page number 4. So I have here, solve. Is 2 to the 4 equals to 2 times 4? Explain. Okay? 2 to the 4 is not equals to 2 times 4. So in this case, I'm going to start with no. Okay? Why? Because 2 to the 4 means that 2 used as a factor 4 times. So that means we are going to, if I have 2 to the 4, it means that we are going to multiply that base 4 times. Okay? So this is equals to 16. And 2 times 4 is equals to 8. So in this case, you can write here, let me put it here, 2 to the 4 means 2 used as a factor 4 times. And that will be something that you can write in that problem. Let's do problem number 6. A bacterium cell splits into 2 cells every hour. So this is really important information that we have here. So it splits into 2 cells every hour. You need to write and evaluate an exponential expression to find how many cells there will be in 6 hours. So I have 6 hours, okay? I'm going to underline cells there will be in 6 hours. Then use your answer to help you find the number of hours. It will take for there to be 1,024 cells. You need to show your work, okay? So in this case, what I'm going to have, I have 2 cells, and they split every hour. But how many hours? 6. So I have 2 to the 6th power, okay? The base is 2, the 2 cells that are going to split, and the exponent is 6, the number of hours. So this is equals to 2 times 2 times 2 times 2 times 2 times 2. We are evaluating. And this is equals to 64. If you multiply 2 times 2 times 2 times 2 is 4 times 2, 8, 16, and so on, until you get 64. Now, you have, then use the answer to help you find the number of hours it will take for there to be 1,024 cells. So here, 1,024 cells. So you have, in this case, 2 to the 6 is equals to 64. Okay? Now, look at this one. 2 to the 7 is equals to 64 times 2. Why? Because we add one more 2. So 64 is 2 to the 6. So if I have one more unit, we are adding one more 2. So this is equals to 128. So let me add one more. 2 to the 8 is equals to 128 times 2 equals to 256. We are finding that number. So, and I continue that way. So 2 to the 9 is equals to 256 times 2 equals to, in this case, 512. And then 2 to the 10 equals to 256 times 2 equals to 1,024. That's the answer that we are looking for. Okay? That's the answer that we are looking for. So 2 to the 10 is equals to 1,024. So what is the question? Help. The number of hours it will take there to be 1,024 cells. So the solution in this case is in 6 hours. There will be 64 cells. Okay? And then you can write there will be 1,024 cells in 10 hours. Okay? In 10 hours, you're going to have 1,024 cells. Okay, number 7. The population of California is about 39 million people. Is this greater than or less than 10 to the 7th power? Explain. Okay? So in this case, I have 39 million. And then I have 10 to the 7. Okay? So 10 to the 7 is 10 million. Okay? This one is 10 million. You can use a calculator. You can multiply. Look at the 7. Look at the exponent. If you have 10, look at the exponent is 7. How many zeros do I have? 1, 2, 3, 4, 5, 6, 7 zeros. So the exponent, if you have 10, the base is 10, and you have the exponent, it gives you the number of zeros that you have. Now, which one is greater? The question, let's look at the question. Is this greater than or less than 10 to the 7? Is 39 million less than or greater than 10 to the 7? So the solution in this case will be greater than. Greater than, okay? And you can explain here, 10 to the 7 is equals to 10 millions. And 39 million is greater than, that's the inequality sign, is greater than 10 million. So in this case, that will be your solution. Let's move to number 8. Number 8 says, write each of the numbers 1, 8, 27, 64, and 125 as a base raised to the third power. So that means we're going to have to the third power. The power is going to be 3. So now we need to figure out the base. So in this case, 1 is always going to be their own base. So 1 is 1. Then I'm going to move to 8. Okay? What can I do? I usually use the composition of a number. Some people will say factorize the number or Look, some people use the 3. So you have 8. A is divisible by 2, which is what? 4. Then 4 is divisible by 2, which is 2. So how many 2's do you have? 1, 2, 3. So the base is 2, and the exponent, count these 2's. 1, 2, 3. That's what we want. So it's 2 to the third power. Then you have 27. 27, in this case, you can do exactly the same. But in this case, 27 is divisible by 3. Okay, is 9. 9 is divisible by 3, which is 3. So where is the base? 3. Where is the exponent? Count. 1, 2, 3 to the third power. So 27 is 3 to the third power. And we continue. 64. In this case, 64, I'm going to say 4 to the third power. 4 times 4, 16 times 4, 64. 125 looks like a 5. 1 is divisible by 5. So 5 to the third power. Okay, that's number 8. Then, look at the problem number 9. The exponential expression 2 to the 8 has a value of 256. Write 2 other exponential expressions that have a value of 256. Explain how you got your answer. Begin by writing out 2 to the 8 as the product of 2's. So what they are asking me to do, that's the question, what they're asking me to do. So for example, in this case, we are going to have 2 to the 8. So you can transform that one as 4 to the 4. Okay, that's one possibility. And then you can do that one as 16 to the second power. Okay? So in this case, you know if you multiply those ones, you're going to have 256. So it's up to you in this problem to find those groups. For example, if you have 2 to the 8, 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. One more. Times 2. Okay, this is equals to 256. Then you can group them, okay? So if remember in class we did it, the group. So what you have? 2 to the second power, okay? 2 to the second power, 2 to the second power, 2 to the second power. What is that? That's 4. 4 times 4 times 4 times 4. That's where you get the 1, 2, 3, 4. 4 to the fourth power. Okay? If you group these ones, now look at this one. 4 times 4 times 4 times 4. If we group them, what you have? What is 4 times 4? 16 times 16. So 1, 2. So it's 16 to the second power. And all those ones are going to get you the same solution. Okay, so I'm going to start with problem number 9. If you have any question, please remember to email me or write a message so we can go over those problems. So you have a great day.